Hello everyone! In this video, I'll give you a quick demo on why we use GPU for deep learning and how it is beneficial to you in increasing the computation speed. Now, the question is it that important? Okay, just imagine this, that you are working on a complex problem and you get the initial result itself, it will take good 12 hours. And after the initial run of 12 hours, if you want to change something in your model, say learning rate, epochs and number of neurons in a layer, now again to complete the next trial run, you will take another 12 hours. So for each trial, you have to wait for 12 hours. In that case, you will be progressing very slow. Hence, to reduce the computation time, we will be using the deep learning frameworks such as TensorFlow and Pytorch, where the libraries are developed in such a way that it can take the advantage of parallel processing and faster computations on GPU. And yes, with the use of GPU, we can reduce the computation time to a great extent. So guys, I have already written the code for the purpose of this video, and here I am using the Pytorch framework for the demo purpose, that is Torch library. Okay. Now just to summarize here, in one of the cell, I have created a loop that runs for 1000 epochs. And inside each epoch, I have generated two NumPy arrays with 1000 elements for each x and y respectively. And then I have performed the addition on it. So guys, in the same way, I have performed the same action using Torch library, but I have created the elements on GPU. So instead of NumPy arrays, I am using the tensors from Torch library and created on graphical processor units. Okay. I have also used the magic command, that is time, on each of the cell to capture the computation time. Okay guys, I'll now execute the cells here. We now have the results, and as we can observe here, that is the computation time in NumPy is around 80 seconds, and the same computation on GPU with the Torch library just took less than 70 milliseconds. Wow, that's amazing speed. Now, this time let's perform a little complex operation, something like matrix multiplication. So for that, I have just changed the operation from addition to matrix multiplication here. And now let's check the computation speed. Now this is interesting. We now have the results. The matrix multiplication on NumPy arrays took around 159 seconds. And the same operation on Torch tensors just took 284 milliseconds. That's really awesome, guys. That means the computation which takes more than a day with NumPy arrays can now be performed in a matter of few minutes. That's how fast it is to perform the computation on GPU using Torch tensors. So with a higher computational speeds, we are now able to progress faster and able to get the required result in very short amount of time. And guys, the total number of loops that I have used for this example is 1000. And even though it may sound too much at first time, but believe me, there are times where we will come across millions of parameters when we are solving a complex problem related to computer vision. Hence, the computation speed matters when performing deep learning. Now, I'll say this again, that is, to be able to perform computations with tensors created on GPU, you need to have a CUDA-enabled GPU. But what is this CUDA? I can say this CUDA as a revolutionary parallel computing architecture from NVIDIA. And with this CUDA compatible GPUs, it is possible to perform the mathematical calculations on graphics processor itself instead of CPU, thus resulting in high computational speeds. So in the example which I have used here, that is, I have created the tensor on GPU using torch.cuda package. And by creating the tensors with this package will enable us to utilize the GPU for computation. And if you're not sure that whether your system has CUDA enabled GPU is present or not, then you can make use of this isAvailable method. Okay. For that, I'll call as torch.cuda.isAvailable. Yes, we have the output that says true. That means we have got a GPU that supports computation on it. Now, to check how many devices are available to us, for that we are going to call the device count method. Yes, device count method, which is present inside the torch.cuda package. So it would be like torch.cuda.device count. And we have the output as 1. That means we have one GPU available for us. And now let's check the name of GPU. For that, we make use of getDeviceName. Yes, getDeviceName method. For that, I'll write as printf torch.cuda.getDeviceName of 0. So we have the output as Tesla P100. And this is the GPU which has been assigned for me. And it is just randomly assigned by the Google servers, nothing in particular or any kind of pattern here, okay? And this NVIDIA Tesla series is actually a universal deep learning accelerator, which is ideal for distributed computing environments. And guys, we have been given for free from Google Colab for learning purpose. So guys, you can check out more about GPU assignment in NVIDIA website. You get all the information over there, okay? So guys, I hope you now know as why we use GPUs for deep learning and how to check its name and also performing the basic checks using Torch library. So in the next tutorial, let's learn as how to create tensors directly on GPU. So till then, see ya!